This video is going to discuss how to solve literal equations. To begin with, we are going to talk about what a literal equation even is. So what is it? A literal equation is an equation that involves more than one variable. For example, I have this equation right here, and I notice that there's an x, a y, and a z. So this would be an example of a literal equation. Equations like 3x plus 4 equals 10 would not be an example of a literal equation because there is only one variable. However, I am still going to solve in very similar ways. My very first step is to locate the variable that I'm supposed to solve for in the equation. I'm going to locate and I'm going to somehow identify it. Step number 2 is I'm going to isolate the variable by using inverse operations. For example, if there is addition, I'm going to use subtraction. If I see multiplication, I'm going to use division. And those go back and forth either way. Let's go ahead and talk about a few examples. If I want to solve for a in this problem right here, step number 1 is to identify the variable. So I like to put a box around the variable, and it just lets me know where it is. I can more easily see it. I always draw my line down my equal sign to make sure I can see the two sides of my equation. Now I only need to get rid of, or I need to isolate a by getting rid of whatever else is on the same side. So I don't need to do anything with this 14 because 14 is on the opposite side. I do need to get rid of b. In order to get rid of b, I'm going to ask myself the question, how is b being combined to a? And I can see that b is being combined to a with addition. So to undo addition, I'm going to use subtraction, and I would subtract b. Remember, if you do it to one side of the equation, you have to do it to the other. So on the other side, I'm going to write minus b. On the left side, the b's cancel, and I am left with a is equal to. Now here's the odd part. Normally when I subtract, I can simplify. But notice 14 and b are not like terms because 14 doesn't have a b attached. That means I'm going to write this side to side instead of up and down by writing 14 first because it comes on top, and then minus and immediately after b. Now that a is by itself, I have completed my problem, and that would be my answer. Let's go ahead and look at the next example. The next example asks me to solve for x. I'm going to identify my variable in the actual equation. So x is right here. Now, if you have forgotten what operation is going on between 32x and y, remember that if there's nothing written there, then it's not addition or subtraction or division. There's imaginary multiplication signs. So in order to undo that multiplication, I'm going to do the opposite and divide. And I can divide by 32. And I also am going to divide by y. Because they're both being multiplied at the same time, I can divide them at the same time. Here's my line to separate out my two sides. And I'm going to divide by 32y on the other side as well. What am I left with? 32, timesing by 32 and dividing by 32 cancels out those. Timesing by y and dividing by y eliminates those, and I'm left with x, which is exactly what I wanted. And on the other side, I'm literally going to cut and paste this below. Notice w cannot be divided by 32 or y, so I can't simplify that, and that would be my answer. On this third example, I'm asked to solve for w. I identify where it is, and I'm going to work on a plan to isolate it. The only thing that is on the same side of w as w is this 2. Since this fraction bar acts as division, the way I'm going to undo it is to multiply, and I'm going to multiply both sides by 2. When I times and divide, That eliminates that, and I have w is equal to. Now I have two options. I can write my answer as g times 2, but in math, we always simplify our answer. When I have a number and a variable, I put the number first and the variable second, and that represents 2 times g. That would be my final answer. All right, so all of these problems have been done in one step. So let's take it a step further and talk about solving if I have more than one step. All right, on this problem, I need to solve for r. That means I am going to undo everything else that is on the same side as r. Notice p is on the opposite side, so you don't need to mess with that p. I'm just going to worry about the s and the minus 3. So how am I going to move those? Well, if I have this s and this minus 3, all I need to do is I'm going to work farthest away from my variable to closest. So I'm going to get rid of this negative 3, or minus 3. Okay, and I'm going to do the opposite. The opposite of minusing 3 is adding 3. So I'm going to add 3 to both sides. That eliminates it from this side, and I'm left with p plus 3. Notice I can't combine those, so I wrote them side to side, equals r plus s. Ask yourself the question, is r by itself yet? And if the answer is no, identify it again and ask yourself, how is s being combined? Well, it's being combined with addition, so I'm going to use subtraction. And that results in, okay, I cannot subtract p from 3, and I cannot subtract s from p or 3, so I'm going to write them just side by side. And that would be my final answer, as r is finally by itself. All right, next problem. I want to solve for x. I'm going to draw my line. I don't need to worry about z since it's on the opposite side. On this problem, like I said on the last problem, you're going to work furthest away from your variable to closest. Think about if you had the equation 5 equals 2x minus 1. If I were to be solving for x, remember that I would want to get rid of what's being added or subtracted first, and I would add 1 to give me 6 equals 2x, and then I would divide by 2 to get rid of the 2. I'm going to be working a very similar process on this example, even though there's multiple variables. So let's begin. Just like on this problem up here where I got rid of what was being added or subtracted first, I am going to work on what is being added or subtracted on this problem. Remember, this is a subtraction sign, so I am subtracting 7y from x. So I'm going to undo that subtraction by adding 7y. That gives me the result of, now these cannot be combined because they're not like terms, so I'm going to write them side by side. Z comes first because it's on top, equals 3x. Now how do I get rid of the 3? Remember, it's multiplication, so to solve I'm going to divide. That means my final answer is z plus 7y, all divided by 3, and I'm dividing everything by 3, is equal to x. Notice I just copied and pasted this below, and the 3 canceled out the 3. So this would be my final answer. If I am solving for b, here's b inside of my parentheses. My very first step is to simplify this. I am going to distribute so that I can get towards that b. So to begin with, I am going to distribute. So I have 2b plus 2a equals r. I'm still going to keep circling b because that's what I want to solve for, and I'm going to figure out how to get b by itself. R is on the other side, so I don't worry about that. And I'm going to get rid of whatever's furthest from b first. 2 is being multiplied, so that's the closest. I'm going to get rid of what's being added. I'm going to subtract 2a because I'm adding 2a. R minus 2a equals 2b. I'm going to finish by dividing by 2, because that's multiplication, and my answer then, I'm going to copy and paste it right here, and that would be my answer. Now this next one says solve for y. It might look a little trickier because h is on the other side, but remember h can still be distributed from either side. I'm going to distribute or multiply h into both of those parentheses. 5h plus yh equals c. If I'm solving for y, I don't need to worry about the c. I'm going to get rid of what's being added or subtracted first. So I'm going to get rid of 5h by subtracting, and I am left with c. C comes first because it's on top. Minus 5h is equal to yh. I still want to solve for y. So how do I get rid of h? I'm going to divide it because it's multiplication. I'm going to divide everything by h. So my final answer is c minus 5h divided by h equals y. And I'm going to stop there, and that is my answer. In order to solve a problem with a fraction and parentheses, I'm going to take a slightly different approach. I still want to identify where my variable is and draw my line separating out what I'm needing to get rid of and what I'm not. I'm going to leave a alone because it's not on the same side as c. But instead of distributing, which is going to give me more fractions, which I don't want, I am going to take a different approach. Because this is multiplication, I am going to divide by 3/5. In math, we can't divide or leave fractions divided by fractions. But I still want to divide. Remember that if I wanted to divide by 3/5, that I am going to do the following steps. Dividing by 3/5 is the same as multiplying by the reciprocal, meaning I take my fractions and I flip it. Notice instead of 3/5, it's 5/3. So I am going to multiply both sides by 5/3 times by 5/3. Well, what does that result in? On this side, it just results in 5/3 a. And on the right side, when I times and divide by 3, they cancel out. And when I times and divide by 5, they also cancel out. Without a number in front of my parentheses, I can get rid of those parentheses. So b plus c. My next step is still to get c by itself, and because b is being added to c, I am going to subtract. That means my final answer is 5/3a minus b equals c. Let's try another similar one. If I'm solving for h, notice h is in the parentheses. Distributing the 1/5 is going to give me a more complicated problem. So I'm going to get rid of the 1/5 to begin with. Instead of dividing by 1/5, I'm going to multiply by the reciprocal. So I'm going to multiply by 5/1, which is just the same as timesing by 5. So I'm going to multiply by 5/1. 1 and 1 cancel, and the 5 and the 5 cancel. I'm going to times the other side of my equal sign also by 5/1. And I'm left with 5f equals, now that all the numbers in front of the parentheses are gone, I'm left with g plus h minus k. My goal is to solve for h. In order to get rid of g, it's being added to h. In order to get rid of k, it's being subtracted, and because they're both being added or subtracted, it doesn't matter which one I get rid of first. Since g is being added, I'm going to subtract it. So 5f minus g equals h minus k. Still want h by itself. K is being subtracted, so add k. Add k. And notice none of these are like terms, so I'm going to leave them all separate. 5f minus g plus k equals h, and that would be my final answer.